Good morning. This is pre-algebra for Monday, May the 4th. We're looking at lesson 90 today. What we're going to talk about is not hard, but I will say it is one of those topics that most of the kids in my introduction to algebra class, it took a little while for them to get it, so I need you to pay very close attention. We're going to talk about one thing that we know, and that's volume. How do you find volume? Total area times height. Now I want you to think about that for a second. Volume is a container, right? How much can we put inside the container? So there is a measurement that goes up the container. Doesn't matter if it's a circle or a box or a triangle. I'm going to use, right now, I'm going to use this book, okay? This book has if it were hollow and the side was folded in and it could fill up, we would say whatever I can pour inside the book is its volume. The area from the bottom of the book to the top of the book, all the way around, okay? So the front, the back, the side, and the side, but only the part that goes up and down. I'm not counting the top of the book. I'm not counting the bottom. Only the two sides, the front and the back, everything that goes up and down. If I add those four sides together, that gives me the lateral surface area of my book. The word lateral is going to refer to the up and down part, okay? So in our room, we have over here this wall that has all the color. So from the ceiling to the floor on that wall, on the back wall where all my pictures are, from the top to from the ceiling to the floor. Over here is Mrs. Turner's ledge that looks out into the hallway. So from the top to the floor, and in the front, from the top of our ceilings to the floor where our chalkboards are. If we only measure the walls, the area of the walls from the floor to the ceiling, but we're covering them, okay? That is the lateral area. Now, if I wanted the entire surface area, and that's the third thing we're going to talk about, the surface area of our room, well, I have to have the area of all four of our walls, but I also have to have the surface area of the ceiling and the surface area of the floor. Now, that's only practical. Lateral area is used every day. This is something that many somebodies are using today as we talk. Somewhere in America, many people are using this. If they are painting a room in their house, they have to calculate the lateral area in order to get enough paint, or they get to go back to the store and get more, or they overbuy, okay? So you can calculate, because they're gonna ask you, well, how many square feet of walls are you trying to paint? They're asking you for the lateral area of the room, okay? That's one, okay, one way. If your dad works construction, he has to know how many sheets of drywall he needs in order to cover a wall. He's calculating the lateral area of that wall, okay? So that's something we use a lot, okay? We obviously find the area of our floor anytime we're laying tile or carpet. We find the area of our ceiling, very exciting for us. That big hole that was in our ceiling is all gone. Brother Kurt came in and he put all new tiles over there. Now he had to know how many he needed. What was he finding? He was actually he was calculating the area of the hole. So he knew how many tiles he was going to need. So area is something we use frequently. Now, I want you to turn in your book to lesson 90, and we are going to talk about area. So let's start with something that we know. Let's start with this diagram. If you want to see it in your book, if you're going to make fun of Mrs. Turner's drawing, go to page 255, and it's number 10. That's the diagram we're going to use, okay? Number 10, that's the diagram we're using. So when you look at that, you see that we have one right corner. I have that right here. You can tell it's a right corner because Mrs. Turner's going to draw that little square. What does that tell us? Well, it tells us that the angle is a perfect square, or it's 90 degrees, no matter how badly Mrs. Turner drew the diagram. Notice that this side, though, is slanted. And of course, at the top, we have a semicircle. First, I want to find the volume of this. How do I find the volume of this shape? Volume equals the total area times the height. Let's look at our story problem. It says, find the volume in cubic feet of a right solid whose base is shown and whose sides are 4 feet high. So what's the height of my diagram? It's 4. So I can go ahead, I've written my formula because you've written your formula, right? All right, now we're gonna look at this and we're gonna say to ourselves, what shapes do we have in this? Okay, well, we have a semicircle. We're going to have a rectangle, but we're going to have to do what? Draw a line to square this off because this is not a square. And in order for it to be a square and use the square formula, this line would have to go straight up and down. And because it slants, we can't. So to find our total area, we're going to have to find the area of the square plus the area of the triangle, which is right here, plus the area of the semicircle. Once we have those 3 areas, we will know what our total area is. Again, this is not a new process for you. And then we're going to multiply by the height. Now, let's take each of these. Okay, we're going to first look at the area of the square. Well, we know that it's 10 feet this way. If it's a square, it's also 10 feet this way, correct? So we're going to go to the area of our square. The volume equals 10 times 10 plus. Now that's the area of the square. Next, let's do the area of, let's do the semicircle at the top, okay? Because that's probably the one that you all least like, you all least enjoy doing the most, okay? All right, so for the semicircle, what do we know? Well, we know that the radius is 5 feet. What's the formula? Okay, our formula to find, I'm going to switch these around so that they match what we're doing below. Okay, so we have the area of the square. Now the area of the semicircle, we're going to say pi times, 5 is our radius, but what's the formula? Pi times radius square divided by 2. Okay, now we have to find the area of our triangle, which is base times height divided by 2. All right, so what's the base? Well, we know that the first 10 feet belongs to the square. How much is left? Well, if it's 15 all the way across, the first 10 are part of my square, there's 5 left. So first we have 5. Now we have base times height. What's the height of my triangle? It's going to be 10. And we're going to divide by 2. Okay? Does everybody see where I got those numbers? Okay, that is my total area, and this is going to be in what? Square feet. Then I'm going to multiply by the height, and our story problem told us that it was going to be 4 feet. Okay, so now let's solve. 10 times 10 is 100, plus we have pi times 5 squared divided by 2. Okay, and then we're also going to have 5 times 10, which is 50, divided by 2. That's going to be 25. We're going to put that there. Then we're going to say 5 times 5 is 25. 25 divided by 2. We're going to say 25 divided by 2, and which is going to be 12 and a half. And we're going to bring our pi down. Say, Mrs. Turner, why didn't you solve that? Because I may have another decimal, and this is just going to make it easier, okay? And then we're going to say, whoops, times by 4 feet. Now let's add all of this together, okay? So now we have 100, we're going to say 100 plus 25 plus 12.5, and we're going to multiply by 3.14, okay? When I do that, I'm going to have 164.25, and this is going to be, again, square feet. Multiply that by 4 feet. What do I have now? I simply have to multiply. So I'm going to say I have 657 cubic feet. Now that's a problem that we've done many times. We have done this type of problem. What I want us to look at next is what we call lateral area. Remember, lateral area is what goes up and down. How do you find lateral area? It's so easy. Find the perimeter of your shape, find the whole perimeter, multiply it by the height. All there is to it. Make a note of that somewhere where you can refer back to it because you're going to need it many, many times in the next few days. So lateral area, remember, by definition, it's the square area that is up and down, okay? And how do you find it? Perimeter times height. So let's look at our shape again, okay? Look at the shape. We have to find its perimeter, okay? So we have 15 and we have 10. How are we gonna do that? How are we doing it? What are we actually finding? The length of a chord. So we wanna go from here around to here. So we're gonna say pi times diameter divided by 2. Mrs. Turner, I don't know what the diameter is. Sure you do. What's the radius? 5. So what's the diameter? 2. Okay? So I'm gonna move this up. Lateral area equals perimeter times height. That's just to give us a little more room. Okay? So our perimeter is gonna be 15 plus 10 plus 11.2. Okay? So our lateral area in that case is gonna be 36.2. Now let's go back and do that semicircle. Remember what I said it was? Pi times diameter divided by 2. So we have pi times 10 divided by 2, okay? So pi is 3.14, okay? So I'm gonna write that down so you can see it. Pi is 3.14. If I'm multiplying by 10, I'm simply gonna move my decimal point one place, okay? So that makes it 31.4 divided by 2. So our lateral area is 36.2 plus 31.4 divided by 2, okay? And then we have to, I'm sorry, I forgot to write this on there. We're gonna multiply by the height, okay? What is the height? Well, we learned over here that the height was what? You write this up here so you can see it a little better. We know that it is 4. So we're gonna divide, we're gonna get 16 divided by 7, okay, 0.7, and we're gonna add that to our 36.2 and multiply it by 4. So our lateral area is going to be 207.6 square feet. Okay, what did we find? Lateral area. How do you find lateral area? Find the perimeter of your shape, then multiply it by the height. Next is the surface area. Surface area is when you have a shape and you want to Christmas wrap it. You have to have the measurement of the area of the top and the bottom, which is going to be the same, the side and the side, which is going to be the same, the front and the back. If I were doing this book, I would simply say 2 times the area of the top plus 2 times the area of the side plus 2 times the area of the front. I would find those 3 areas, add them together. That's my surface area. Why? Why did I say 2? Because find the area of the top, multiply it by 2 because the bottom matches it. Find the area of this side, multiply it by 2 because this side matches it. Find the area of the front, but multiply it by 2 because the back matches it, okay? Surface area is when you want to Christmas wrap it, okay? Christmas wrapping, that's what it is. So what if I wanted to Christmas wrap this really weird shape? I don't know why. Who knows what kind of Christmas present that would be? Here's what you're going to do. You're going to say, what is the surface area of a weird shape, okay? The surface area is 2 times the area of the base. Why? Because when I find the area of the base, I'm automatically finding the area of the top, right? Because they're going to be the same. So when I take 2 times the area of the base, I found the top and the bottom. Now I can simply add the lateral surface area because I've already found that. Okay, so let's go back. Lateral surface area is the perimeter times the height. That gives me the lateral area. Okay, when I want to find the surface area of a weird shape, find the area of the top, which is also the area of the bottom. Find the area of one of those, multiply it by 2, and then add your lateral surface area. Okay, so we're going to find the area of the base. How do you find the area of the base over here? Well, the area of the base is going to be what? Well, we already found it. We found our total area, right? We found the area of our base when we said we took 164, which is down here, okay? 164.25. I didn't use my bottom answer. That's the volume. That already included the height, and I don't want to do that yet. I want to take 164.25. And you know what I'm going to do with that? That's the area of my base. What am I going to do? What does it say? Multiply it by 2 because the bottom and the top are going to be the same. So I'm going to multiply that by 2, and then I'm going to add my lateral surface area. Okay, write that in from my earlier problem. So I'm going to say 164 times 25, or I'm sorry, 0.25 times 2, 328.5 plus my lateral surface area, which was 207.6. Now, all I'm going to do is add those together. What am I adding? The total area of the base times 2 plus the lateral area. Now, this video is going to have a very hard time going up. Okay, so it's going to be 536.1 feet squared. Okay,